Hi guys, so my job today is to talk to you through the concept of asynchronous of our first asynchronous class and the concept of limits of composition functions. So first of all, let's talk about composition functions. We saw that in week 1 when we reviewed f of g of 2, where you plug in something, you get an answer, you use that answer, and then you get another answer. So when we talk about composition functions, we're looking at something like this notation at the top where it says the limit as x approaches a of f of g of x. So we have a inside function here, and then we have our outside function here. And you're going to see this a lot of writing in these bullet points. That's just kind of summarizing the process that we do. But what we do need to do is we need to figure out what the limit of this guy is first, and then figure out, is it all above, is it all below, or is it straight through? So let me get to what that really means, okay? So here we have this function. We have g on this side, we have f on this side, and it says find the limit as x approaches 3 of f of g of x of this function. So the first thing that we need to do is we need to come in here and we need to figure out what is the limit as x approaches 3 of the function, and then figure that out. So let's go over here. Now, if you were in my classroom, you know that I used my little man Howard here, and I said, okay, x approaches 3 from the left and right. Well, here's 3 on the graph. So from the left, Howard ended up at 2, and from the right, Howard ended up at 2. So we can see that from the left and the right, Howard met at 2. He's staring at his reflection, okay? Now, there's one other little thing that we've never talked about before, and this is specific to composition functions. And that is, do you notice that this function, yes, from the left I came to 2, and yes, from the right I came to 2. But do you notice that all the y values right here close to this value are below the function? Do you notice that? So first, we did the limit of the inside function, and we got that the answer was 2. But we got that 2 was from below on the left and the right. So what you're going to have to do on the next thing, and now that you've done the inside function, you're going to do the limit as x approaches 2, because that's what you found, but you said from below, so that is going to qualify as from the left of f of x. Okay, so let me just walk through that again. We figured out what the limit was of g. We said it was 2, but we noticed it was from below on both sides, and that makes it 2 from the left when we do the outside function. So now we're going to go to this next graph, and we're going to do the same thing, and we only want from the left. So here's x equals 2 right here, but we only want Howard traveling on the left-hand side of the function. So we come up to 2, and we see that little thing, and it might be a little bit hard to read because the font is small. I'll try to work on that later. And that is your answer, 5. So notice I had to do 2 things here. The first thing I had to do was do a limit of an inside function and analyze it to make sure that it was either from the top, from the bottom, or it just went straight through. And because it was from below, then in the next step, when we do the outside function, we only look from the left. So I bet you can probably tell what we're going to notice in the second example. Okay, so here we go with our second example. I have the function f of x, h of x, and I want to find the limit as x approaches 3 of f of h of x. So the first thing I'm going to have to do is I'm going to have to come in and find this inside function. So we're going to take care of this guy first. So the limit as x approaches 3 of h of x. So h of x is on my function. Let's notice right here next to the 3, there's no plus or minus sign. So when there's no plus or minus sign, you got to check from both the left and the right. Well, here's x equals 3 on my screen. Howard from the left ends up at 2. Howard from the right ends up at 2. So our function limit here is 2. But this time around, both of my things came from both from the left and from the right came from the top. So this time around, because the 2 is from the top, when we do the outside function, so the limit as x, or I should say x, I don't know why I wrote h right here. I should have written x right there. X approaches 2 from the top means I only want the right when I do the outside function. So the limit as x approaches 2 from the right of the function equals, so let's get Howard and let's pull him on from the right-hand side. And here is x equals 2 right here. So where do you approach from the right? You approach at -1. So your intended height from the right is -1. So notice again, I had to analyze. This is a composition function. The first thing I had to do was recognize it was a composition function. That's the first half of the battle. Then the second thing was find the limit on the inside. Then the third thing was analyze that answer. Did it come from the top? Did it come from the bottom? Or did it go straight through? And then use that to do the outside function. Okay, let's see another example. We're going to do 2 more examples. Okay, so here comes our next example. We have the limit as x approaches 3 of f of j of x. So f of j of x, composition function. So step 1, find the limit of just the inside function. So I'm going to say, okay, what's the limit of limit as x approaches 3 of j of x? There is no sign next to the 3, which means I need to find it from both the left and the right. And you can see from the left, as I approach x equals 3, the intended height is 2. From the right, as I approach x equals 3, the height is also 2. Okay, so now a question for you. Do you notice that the function came from the bottom and the top? So this was both. Okay, and so it's like, I'm going to write here both top and bottom. Okay, and because it's both top and bottom, then in the next step, I do the limit as x approaches 2, but I'm not going to write anything right here because from the top would have been a plus sign, from the bottom would have been a minus sign, but it's from both. So I'm not going to write any distinction. So now I'm going to do this function, and hey, now I'm doing the limit as x approaches 2, no distinction. And when there's no distinction there, that means you got to check both of them and they have to match. So let's go to this graph and say, all right, there's x equals 2. And as I approach x equals 2 from the left, I'm at 5. But as I approach x equals 2 from the right, I'm at -1. Howard didn't match. He's not looking at his reflection. So that means that there is no limit. Lindsay Lohan, Katie Heron, she is basically saying the limit does not exist. Okay, so again, first, have to recognize I have a composition function. Do the limit of the inside, get an answer, analyze that answer, because that's going to influence how you write the notation of the next problem. If it was only from the top from both sides, you write the limit as x approaches, let's say 2 from the plus side. If it was all from the bottom, limit as x approaches 2 from the left side, the minus. If it came from both sides, you don't have to worry, and then you just do a limit as usual. Okay, we're going to do one more composition function. This one's even the trickiest of all. It's very common. You'll see it on your AP classroom when we do progress checks and things like that. It says the limit as x approaches 0 of f of the function 1 minus x squared. But over here, it told you the graph of it told you the graph of f was this function right here. Now, the common error is for students to go, okay, I'm just going to put the 0 in here. And what is the limit as f of 1? And then they come to this function and they're like, oh, there's a break in the graph. That means Howard's not going to see his reflection because the limit from the right and the limit from the left are going to be 2 different things. We have ourselves a composition function. Okay, so if I were to look at this composition function, here is my limit and here is my inside function. So I have to find the limit as x approaches 0 of 1 minus x squared. Now, do you remember? We've been dancing this week. Do you remember the graph of 1 minus x squared? If you forgot, the graph of 1 minus x squared, where x squared is a parabola that looks like this. So a minus x squared would be a frowny parabola like this, and then the 1 would just shift it upwards 1. So I'm going to sketch that over to the side. So we have a little parabola that looks like this. We have the point 0, 1. This is why dancing is really awesome. If I know my beautiful dance moves, it helps me create these graphs. If I don't, I have to create a t-table where I'm like, all right, when x equals 0, what's y? When x equals 1, what's y? When x equals -1, what's y? And then I have to graph all these points to be able to graph it. But if I know my beautiful dance move, I can just sketch it. All right, so let's look at this. We get limit as x approaches 0 of the function 1 minus x squared, which I just sketched over here. So if I was to bring Howard along for my ride here, Howard's going to go, all right, as I approach 0, I'm at 1. And as I approach 0 from this side, I'm also at 1. Kissy, kissy. All right, so we have the answer is 1. But do you notice that Howard came from below both times? So we know that this was from below. So then when we go to the next part of the problem, we do the limit as x approaches 1 from the left of the outside function. So I don't want from the left and the right. I just want to come over to x equals 1, and I want to see, all right, Howard, how did you get there? And there is Howard. He's at 3. So the answer here is 3. Okay, the most common wrong answer on this problem is for a person to say the limit does not exist, because they just say, oh, the limit is x approaches 0, plug it in. Oh, I'm just looking at 1. I look here, I have a break in the graph. That's not right. You have to recognize composition function. Do the inside. Did the inside come from just the top, just the bottom, or did it go through? And then set up your next thing for the outside function and get your answer. I hope that clarifies things. I think you should show all 4 notes in your notebook, but I will also provide this on the Google Classroom. And that is how you would do a composition function. Okay, have a good one.